So this is the first property under circle theorem. So to be able to use it, you have to know that the angle here at the center, provided this is a center, this angle is twice the angle at the circumference. So if this angle is 80, so let's say this is 80 degrees, okay? If this is 80 degrees, you have to know that the angle here, it's a 40 degrees. That's what it means. It means an angle here is twice. So this angle times 2, which is twice, will give you the angle at the center. Let's say you've got an angle here. How do you get an angle at the circumference here? You divide the angle at the center by 2 to get the angle at the circumference. And please note that they must all be coming from the same segment here. Okay? So this is where they're coming. Let's check out another property and see what you're supposed to do. Okay, so this is the second property, and what the second property says, for as long as these angles, they are all coming from the same segment, or should I say the same arc here, they are equal. So this angle is equal to this angle, equal to this angle, provided they're all coming from the same, you see, and they are all touching the circumference. They are equal to each other. So let's say this is 40 degrees. This also be 40 degrees. This one also 40 degrees. So let's check out property number 3 and see what we need to know at property number 3. Okay, so for property number 3, it says that when you've got a triangle, or a triangle has been formed in a semicircle, the angle here, it's always 90 degrees. So let me repeat this. When you've got a diameter, you can see this is a diameter. AC, it's a diameter. And an angle has been formed in the circumference or at the circumference. So at whichever point an angle is formed, for as long as it's touching the circumference, it's 90 degrees. So if you want, you can do this. Look at this. So the angle here, it's also 90 degrees because it's touching the diameter. Can you see the diameter? AC. The key thing here is the line which is passing through the center. And at whichever point a triangle is touching the circumference inside the circle here, it's always 90 degrees. This is what you need to remember. So this is 90 degrees, even this one. Okay. Let's go to property number 4. And see what we need to do on property number 4. This property says that opposite angles add up to 180. So if this angle here, it's 80 degrees, what will be the opposite angle here? It's 100 degrees. Okay? This is what you need to know. They say opposite angles add up to 180. When you add this angle plus this angle, you must get a 180. The same applies to these two angles. If this is 40 degrees, of course this will be 140 degrees. We must know that when we add these two, the answer must always be 180 degrees. This is what property number 4 says. Let's go to property number 5. So property number 5 says that when you've got a radius, we know, of course, that this is a radius from the center, a line from the center to the circumference, it's a radius. And it touches the tangent line. So the angle between the tangent line and the radius, it's always 90 degrees. So this is 90 degrees, and this side also it's 90 degrees. Okay, that's it. Not very simple, not very difficult. Let's go to the last property, which is property number 6. So property number 6 says that the angle between the chord and the tangent line, you see this tangent line and the chord, is equal to the angle which is being formed by the chord. You see, this is a chord, so it's forming a triangle. So this angle will always be equal to an angle between this chord and this. So let's say this is 50 degrees. This will also be 50 degrees. What if this is, for argument's sake, let's say this is 80 degrees. What will be this angle? This angle will be a 48 degrees or so.